it's a pleasure to introduce some amazing engineers from Kindred-backed companies. Kindred is an early-stage VC backing some really great businesses, not just software companies, but also companies building stuff for autonomous cars or products that are more including both mechanical and software engineering. So I hope that's going to be a very exciting session. This series is done in partnership with Silicon Roundabout, an amazing community of engineers, one of the oldest in London. And we've been doing these events since half a year now. And the main thought about these events is that we all talk about tech sector, we're all part of tech sector, but so rarely we give space and spotlight to people who are actually building these amazing tech companies. And this is a perfect opportunity to do that. And that's why we're doing it. Without further ado, I'd be very happy to invite Melanie, who's going to be talking about the challenges at Animal Dynamics. And so, Melanie, please join the stage.
Hi, hopefully you can hear me okay.
Yeah, I can hear you perfectly. You can also...
Fantastic. I will share my slides. Yeah. And welcome everyone to this really interesting event. My name is Melanie Demello. I'm the head of engineering at Animal Dynamics. We're a spin-out company from Oxford University, formed in 2015, growing very fast at the moment. We're 62 people. I have a recruitment list of about 20 that we're working on. So really, really exciting times for us. Our vision is to deliver bio-inspired solutions that positively impact both nature and humanity. And by bio-inspired, we mean that we look at how animals have evolved, we understand why they are efficient and effective at what they're doing, and we apply that to our engineering. At the moment, we're focusing on a particular product that will revolutionize the way that payload is delivered. So I'll be telling you a bit more about that. Here's an image of one of our products. It's called Stork. It's a payload delivery system based around a parafoil vehicle. It has no human pilot, so it behaves autonomously, and it's able to take off, fly, go to a particular location, drop a payload, drop multiple payloads, and then land. This particular one is a prototype that's been flying for a couple of years, and we've been working for about 6 months now on a larger version, which is 400 kilos. It will be able to carry 135 kilos of payload. So we're talking to various customers about what they would use that for, and looking to have a flying vehicle early next year to do demonstrations. And really the unique selling points of it are that it's very safe. So if we have a failure of the power plant, it will simply glide because of that wing. It's relatively low cost, low environmental impact, very rugged and robust. We've had customers accidentally fly these into the side of walls and vehicles and sort of bend it back into shape and take off again. So we've got good feedback from our customers so far. We're really excited about what's going on in the world in technology, and we have chosen 3 themes for our core technology development, which will run in parallel with our product development. So these are the areas where we think Animal Dynamics will differentiate itself in the future. So we have a theme looking at autonomy, artificial intelligence. We have a piece of work looking at how bees see the world and navigate. We're looking at how customers will interact, not just with a single vehicle, but with fleets of vehicles. How will they manage those, maintain them, get payloads to the right place at the right time, just make the customer's life easier. And our routes, our bio-inspired routes, are looking at the structures and mechanisms that animals use to move efficiently. So for example, the way that birds modify the shapes of their wings to take account of the weather, We're looking at things like that. So as I say, we're very actively recruiting throughout this year. Right now, you can go to our website and see some of our vacancies. We've got a couple of control engineers vacancies at the moment. We use a lot of model-based engineering approaches. So we use the MATLAB, Simulink, and associated toolboxes to create synthetic environments and then operate our vehicles in a virtual environment to develop the control systems. So that's the skill set required for those two roles. We have a lot of systems and safety work going on. So we're looking for somebody to look at the cybersecurity aspects of the safety of the vehicle and do the risk mitigation of that. Later on this year, we will be looking for software and electronics engineers and more control engineers to support the core technology developments in autonomy and in those cloud-based management services to interact with users, let users plan missions, organize their fleets, etc. So I've just listed the types of languages and approaches that we use at the bottom of the slide there. We tend to take on flexible people team players who get stuck in and do a variety of things rather than being solely focused on one thing for the whole day, every day. That was a quick intro. Very happy to take questions.
Hi, Melanie. I'm gonna ask you one question that I got. How are you kind of like structuring the organization when you have sort of like two distinct parts, like, mechanical engineering and software engineering? How do you make sure that how do you recruit people? Do you expect people to have been working in an environment which mixes hardware and software? If you could elaborate on that a little bit, that would be great.
So we try and use a fairly conventional matrix structure. So we look at what capabilities we need in engineering, so mechanical, software, systems, safety. So we tend to recruit capabilities and then assign them to projects. So we use Jira to do our project management and set up work packages and then assign those to the individuals in the capability teams. So our line management structure, our career development framework, training, personnel management is via the capabilities such as electronics and software, and then the projects get organized effectively at right angles to that organization in a matrix structure. We don't expect people to necessarily have worked in UAVs or in product development before. We tend to recruit very much on attitude and excitement about technology. Depending on the role, of course. If it's a senior role requiring experience, then that would be in the job description. But we're very much recruiting on attitude and people who are excited about what the world's going to look like in the future.
Yeah. And another question is, can you elaborate a little bit about the key technology challenges that you're looking to solve in the sort of, coming 6 to 12 months? You've mentioned about some things that are happening with it. I'm sure that as with every product, whether it's software or mechanical, there are some things problems that you're trying to solve. And usually these problems end up being the exciting thing that is really enticing for people to join an organization.
Yeah, sure. There's lots going on. One area of particular interest is how do we fly beyond visual line of sight, and how do we prove to the regulators that it's safe? So what sensors do we need to put on the vehicle to detect objects, both in flight and then coming into land? So we've got some project work at the moment looking at radar, camera-based systems and LiDAR, and just working out, well, what suite of sensors do we need on the vehicle? And then how do we go on to fuse that data together to give the autonomous vehicle a picture of the environment? And then how does the vehicle make decisions about what it's learned about the environment? For example, if it needs to make an emergency landing, this is one of our particular challenges, and it needs to identify somewhere safe to land that isn't its pre-programmed landing site, and it needs to find a sufficient a field. It can land in sort of 50 by 50 meter field, but we need to look at the ground and say, well, there's no people, there's no vehicles here, there's no threat. And that's a really interesting machine learning challenge, because we need to basically be sure that we're not going to land on somebody, and be able to prove to the regulator that that's safe enough.
Yeah. And when it comes, and that's the last question, when it comes to like particular technology expertise that you are looking for and that is most important for you, what would that be? And it could be both the expertise as well as the kind of problems that you would like to solve, and you're looking for people that have been solving them in the past.
Yeah, so we're as a startup, as you can imagine, we're putting a lot of processes in place at the moment. So as well as the particular software experience I listed on, we're also interested in people who've got experience of creating continuous integration, designing software for test, creating that system in MATLAB Simulink, for example, to auto-code software. So people who can cope with a startup environment where you're actually got to write the processes and develop the processes at the same time as you're actually developing the product. Does that answer the question?
Yeah, there's also a couple other. So Beata asked, Melanie, you are the head of engineering. What is your team structure?
Right, yeah. So I have at the moment a chief engineer of the Stork project, and he has within his area the mechanical, electronic, and perception sensor teams. Then I have a chief engineer who has been helping me set up the technology side of the business. He's now set that up and will be focusing very much on the cloud software, and we're going to be recruiting leads for the other technology areas. So I'll effectively have lead engineers responsible for particular areas reporting into me. So there'll be a chief engineer autonomy that we'll be recruiting very soon, and a chief engineer of the bio-inspired mechanisms and structures area.
Mm-hmm.
And then I also have somebody who just looks after our data, so a product data management person as well.
Yeah. And another question from Megala, when can we expect hiring for software engineers?
So all through the remainder of the year, there will be different posts being announced. So I think, sorry, off the top of my head, we've got about 22 roles to recruit by the end of the year. And they'll go out in batches of sort of 3 on a 1 or 2 month basis.
Thanks for, again, helping organize this amazing event. It's great to obviously partner up with TechTree and keep the engineering community of the UK engaged. And happy to see so many people turning up and great startups. Also great to partner up with Kindred for this event, which in a different way, but still has kind of a community aspect to its fund. We've launched recently our deep tech fund, and looking to raise a bigger one actually at the back of this very micro one, of which we've done an investment, closing another one now, and looking to make another one very soon. So all about supporting companies. For those of you who might have not been part of the community for a while, we actually started back in 2011 as a meetup, and myself being an engineer, I just love the idea that Pavel pitched to me. Hey, why don't we do a series to actually showcase the code and what's going on inside the tech companies from, let's say, our perspective, the CTOs, the engineers, the technical people. So really grateful to be here, and just wishing to enjoy more, and maybe fire up some questions for the next founders.
Yeah, and Francesco, I think it would be great if you could elaborate, because I think you're a very unique value proposition in the UK, that you're a very early sort of like a first check fund focused on deep tech proposition, and you also have a huge engineering community. So I've mentioned a little bit about you being the oldest, the biggest, the best, etc. But maybe you can add a little bit more flavor to it, so people know when they should, reach out to you with what kind of stuff, and if you could give maybe like a 2-minute overview around the community and the fund, that would be fantastic.
Pavel, if you were not the founder of a partner, I will hire you. Like, you're doing a better job than I am, even in my own community. So yeah, like, just to keep it brief and not to waste anyone's time on the founder side, who are literally the protagonists here. Silico Roundabout, like I said, it's been around since 2011, and the fund that we launched is focusing on advanced technology at early stage. We're actually moving away from the word deep tech because people seem to be fixated on Industry 4.0. What we really mean is that we don't really, we're not really going to invest in, say, yet another shallow platform, dating app, or like these type of things. We always want to invest in the next trend of technology, where there is at least a substantial amount of work on the development side. So anything that requires on the software, maybe software hybrid, we don't touch biotech, so software hardware innovation, then we'll definitely be looking at it. The worst case scenario is that you'll be part of an amazing community. You'll get our feedback, and like Pavel correctly said, get to talk tech to our engineers. The other nice thing is that we'll actually talk tech whenever we talk about your company, not just the business pitch, but also how you build tech, because that gets us very excited. And we've been supporting all of our investees so far. In fact, both the one that we're closing on, the one we've already signed, on both the business but also the technical side, bringing our expertise. And then, of course, you need to hire once you get funded, right? So not only you'll be able to join events like this, but also anytime you need to hire and scale up your team, we'll be there to support you. And of course, TechTree will being our partner means that you've got you sort of kill two birds with one stone, right? So definitely, whether you've got an MVP and you're talking to the first customers, where you got initial revenue, you're in pre-seed, seed stage, all the way to sort of the bigger seeds, then definitely come talk to us, and we'd love to discuss more. I'm gonna put the website down in the event chat. I'm gonna go to the event one just to clarify, since there are two chats. And yes, if you've got a startup, reach out, sign up, come to pitch, come to join events like this.
Great stuff. So Francesco, thanks a lot for that overview. I'm sure there's a lot of amazing founders and engineers looking for work. And now, without further ado, I wanted to invite Francisco from 5AI, one of the coolest deep tech or advanced tech businesses in the UK. So Francisco is a software engineer at a company building software for autonomous vehicles. So Francisco, you can join the stage now.
And I'll be dropping off then. Thanks, everyone. Bye.
Hello, can you hear me and see me?
I hear you perfectly.
Excellent.
You can start sharing the screen as well.
See if I can do the screen bit.
Fantastic. I can see it. Yeah,
cool.
Seems to be working. The floor is yours.
Thank you very much. And thank you very much, everyone, for turning up today to listen to me. I'm Francisco, but please call me Paco. I work for Five. I've been at Five for 3 years now. And what I wanted to tell you about today is the kind of problems that we've solved and the kind of problems we are solving now, and why it is a super interesting job that we get to do every day. But all the cool stuff that we do, that would only happen, that only happens because I'm lucky to turn up every day to the office, virtual now. This is my living room, but to the office with an amazing team. So I wanted to introduce the kind of the team we have. So our team is distributed. For the last year, we've all been working from home. We were very early working from home because that was in the safest way, and we adapted very quickly. And we are 135 people roughly. We've got people with PhDs, we've got people with a master's degree, first degree, we've got some vocational training people. We speak at least 32 languages in the office. And we've essentially we've got like 6 offices all across the UK. This team is I'm very lucky because everyone is really good, and there's a lot of collaboration in between teams and offices, and we always strive to do that and to do a bit more of that. And this is more or less what it used to look like at the top, because that's from like some time ago, last time we met all together. And these days we get a lot of video calls. We do it on, we go on Gather Town, and that's how we try and keep the team together and the communications flowing. The way in which we work as a team is sort of more or less we try and adhere to this principle. So as I said, we've got quite a few big questions that we're trying to solve, and we're trying to find the best solution. So we know that we don't know everything, so we're constantly learning. We're always trying to understand it better and to see if there's a different point of view we can take and a better solution that we can bring into. With that, it comes with the fact that we are doing, as Pablo has said, we're doing cutting edge science for some things, and once you get some cutting edge science, you need to, in order to bring that into a product, you need to put it into you need to take your prototype and make it into a well-engineered product. So this is one of the things that we also aim to do, and we spend a lot of effort trying to do that. And sort of the third principle is that we aim and we try and empower everyone in the company to have impact every day. Impact can have many different ways. Sometimes you just fix a very urgent bug, others you'll just help someone who's not having a good day or who's stuck with a problem that happens, and we try and help each other all the time. And at the same time, we also try and remember that, especially over the last year, that we've been behind the screen, and it's only like a name. It's like there's a person. So we try and work as a good team, like rather than a bunch of individual contributors. So we try and aim to just we only win if everyone wins, if that makes any sense. So this is the kind of approach that we have as a team on how we try and make things. And I would say it works well because we've got an excellent team in the company, and that's why I get to show you all the cool stuff that I'm going to show you right now. So first, I would like to start with a little bit of history. So Five has been going for 5 years, and the sort of headline is that we were the first ones to bring self-driving cars to London. We did that as part of, we developed a level 4 prototype, and we took it on the public road in London as part of a project called Streetwise. We took also members of the public, and we did about 1,300 miles of passenger trips in London. And these are some images from that trial. As you can see, we have a safety driver on the car, and the reason why he's got his hand around the wheel is because he's ready to grab the wheel at any point if some risky situation arises, or if the situation goes outside of what the software is spec'd for. Because remember, level 4 has a defined set of circumstances under which you can operate it, so it's not a full autonomy, which would be the level 5. The way we developed this, so I'm gonna play this again. So we took it on. We did it on a lot of miles on the road. We have a circuit. First, we would take it on a closed road circuit. We would do quite a few tests and a lot of testing there. Then once we were sure that release of the software didn't have any regressions or any bug, we would take it into public roads. That was a lengthy process, and as part of the development process, I can recall one day where I spent about 7 hours on the car, and I was just trying this. This was not safety critical, but my aim was to try and smooth the braking, and that involved just standing on the top of a small slope, driving for like a meter or two at 1 meter per second, and then braking, and then reversing, and then doing it again until it was completely smooth. And it was very fun for the first 3 hours. The next 5 were a little bit more boring, I have to say. But the initial development we did, and if you're familiar with the space, you would have seen all the press release over the last few years of all the players saying, "Oh, we've done 1,000 miles on the road, we've done 10,000 miles on public roads." And one of the problems that this has is that it requires a lot of time and a lot of effort And over the last year, most people possibly have not spent a lot of time on a car, but if you have, hopefully you've been lucky to realize that most of the time on a car is quite boring. This is a straight line. There's nothing happens. And when you're testing a system, what you would like to go is you want to go to the close to the failure modes or to the error modes, and you want to find where the bugs are. So that's what you're going for. So part of what we realize is, and you might be thinking this now at the moment, is like, oh wait, so you were just essentially doing everything in the physical world. You were doing, so why didn't you think of, like, creating a realistic physical model of the vehicle dynamics and then have a good simulator that would actually simulate all the different agents and then come up with a way of describing what a driving scene is and how you actually put all the different agents on a scene and how you can recreate what would be a dangerous situation, all in simulation that would be safe. And then once you have that, why don't you run, say, 1,000 or 10,000 simulations? And now that you're doing it, you might as well just automatically analyze all those results and pick up the most important ones, so your engineers can actually spend quality time looking at the most important problems. And that is precisely what we've been doing over the last 2 years. That's we started 2019, and we've been building this software, this sort of tool chain that is that is trying to answer this question, which I know is not a properly formulated question because it's a full system. It's not, so a unit test doesn't apply, but it's quite catchy. So that's why I wanted to place it this way. So what we've been doing is trying to develop the tools to be able to continue doing and improve on what we did with the level 4 prototype, but to do it better, faster, cheaper, and more importantly, safer. And in order to do that, so one of those questions that I've mentioned that we have to start answering, and we had to come up with good solutions, is how do you describe it? First thing is you need to place your simulation somewhere, and that somewhere needs a map. So unfortunately, for a self-driving car or an ADAS system, to do realistic simulation, your Google map or Citymapper map doesn't cut it. You need a slightly more accurate, or quite a more accurate map. And luckily for that, there's an existing standard format. It's called OpenDrive. It is it's quite common in the industry. It has certain caveats. So it's a huge file. It's an XML file. It's quite low level, because if you look at the right, and hopefully that's the one time in your life you have to read an OpenDrive file, it's just a lot of geometries, and you have to define point by point. But it works. It's quite, as I say, it's quite standard. There are a few companies that can create these maps. There are editors that we can use, and that gives us the first layer that we need. You need a map to place all your simulations on. And so now that we have a map, we've solved this problem. This is a solved problem. We've solved this one. What do you do with it? So you need to put your agents. You need to describe your driving scene on top of it. You need to be able to work out what the simulation looks like. And luckily, there's another standard coming up, or there's like Open Scenario 1 and 2, and the first one came out of European and OEMs and tire suppliers, and this is what we adopted. We've done a few internal improvements and optimizations, but essentially we just use the standard. And this allows us to describe all those scenarios that we were thinking about, that you have to drive 100 to 100 miles, or I don't know the numbers off the top of my head. You have to drive a lot of miles on the public road to find something interesting. Here we can concentrate and make every meter of simulation, every second of simulation count, and bring value to both our customers or our engineers that are developing the autonomous vehicle features. Because it's simulation, so you can actually create dangerous situations, and it's fine. It's all bytes and ray tracing. So what does it look like? Again, it's a very low level. It's a very descriptive. It's something that you definitely don't want to spend your days writing an XML file like that, because it would take a lot of cognitive load and it wouldn't make it. So what we've done is we created our 5 scenario editor. It's got a UI. It allows both development engineers, quality engineers, verification engineers to create those scenarios that are important, those scenarios where the car would actually, where you would expect to exercise all the emergency braking or things like that. So you can do that very safely, and you can do it in simulation. And more importantly, you can repeat it every time you make a change to the code. You don't have to go on the road and then drive 100,000 miles. You can drive them in simulation, and that's the sort of the value that we are adding to the tool chain. We are actually making it easier and faster for the teams to develop these features, and essentially to also make sure that there are no regressions included. So once we've got to this point, so we've got a map, we've got the scenarios that describe the driving scenes, we've got our scenario editor, and we've got a nice database in the backend with quite a few of those. How do we? What's the next thing that we would need to do? I mean, so first thing that the first thing that, well, maybe not the first thing that comes to mind, but one of the things that is important is now we want to run it. We don't want to run 10 simulations, we want to run thousands, and we want to run them quickly, because the whole idea of this is like trying and make the whole process faster, so we can find bugs faster and we can improve the development cycle and bring again more value to or make lives easier for the people developing this and make it faster. So how we've gone about it, it's essentially we've put together a lot of technologies, and we've been working on it for a while. We've got a development process that is quite stable. We've got a Kubernetes cluster running on AWS, and on top of this, we work with a microservices architecture. Most of those microservices are written in Python, and if we really need to go fast, we'll go on C++. We try and everything runs on Docker. And our development process is quite mature at this point. So we've got continuous deployment. We deploy to production quite a few times a day. It's what I would say a seamless process. Of course, everything can be improved. It's like what we have is good, but we are constantly looking to improve the process. And this is how we're achieving this hyperscale simulation. This is how, of course, we need to. There are some optimizations. There are things to improve, but we've got a system that allows us to do this kind of simulations. And once we can do the simulations, if you think of it, because most of the interesting things are going to happen in a window of, like, say, a minute. If you run, I'm not even going to go too big. So, but if you run 1,000 simulations, and if you have to ask someone to watch to go through the visualization, we've got 2D, 3D visualizations for those simulations. By the time they get to simulation 555, they've completely forgotten simulation 10. And simulation 10 and 555 could be very similar, and they could have like an important thing. So obviously you have to analyze that automatically. And the way we go about this, so we've created quite a few systems that allows, first you have to define how good driving looks like. Once you've defined what good driving looks like, you have to define what's the limit of the system, because not every system I've said between level 4 and level 5, there's a big gap of features and abilities. So you have to, and then you have to make sure it's like within this setup, within the scope of this system, is that good driving, is it not? And then you have to define what the good rules of driving are. So we can run this analysis. This is like a screenshot of one of our tools, where we can see how the system sticks to some of the rules, and we run this automatically on every simulation, and we can pick up on the interesting cases that then we sort of show to the developers for them to pay attention, and that saves this poor person having to watch 1,000 1-minute simulations and trying to then keep notes of which one was the interesting and which one was a little bit more boring. And so these are some of the questions that we've been looking at. Some of the questions we have partial answers to, others we are still trying to find a better solution. And thank you very much.
Thanks a lot, Francesco. That was so exciting. I feel like we could do an 1.5-hour event talking only about the things that you guys are building. One question that I would want to ask you, also as a person, you've been in the business for 3 years now.
Mm-hmm.
Like it's a completely different pace of launching a product to market than, say, if you're running like a web app or mobile app. Can you speak maybe a little bit on how things were changing when you joined 3 years ago till now? Like what were the challenges back then? What was solved? What are the challenges you're trying to solve now? Because I think it's both like your business and many other are called, tech companies, but your tech company is very different than most of them, right?
Yeah. So when I joined 3 years ago, I mean, even so, we've gone from, we were building the prototype, and we had to make sure that we were running this test sort of physically. We had a bit of simulation, but we were running all these tests physically. We needed to get the prototype working, so there was a lot of like we didn't have at the time. We just had to push with this way, which we knew was not the most efficient and the best way, but we needed to get it to work. And then once we could take a bit of a breather, it's like, okay, we did it this way, but there's a better way. Let's try and take a step back and go and see how we can make this faster. How can we can no incremental changes. How can we speed up the development time by like 100 or more? And that's been the big change. Went from originally we were just building the car and building the prototype to like, okay, how do we also build the tools that would make this process much faster and much more efficient? And also allows us to do stuff that you cannot do, because it's the thing that once if you only have the physical testing, every time you change a line of code, potentially you've thrown away all the previous testing, because technically there could be some side effects to each line you change. In simulation, you can then go and rerun all of that. Obviously, it's not like it's all free and magic. Everything has a cost and you have to do it, but it's a much easier way to rerun a lot of the tests and to improve the development cycle. And in terms of what the company has grown quite a lot. We've had to learn new technologies. We've had to. It's been personally for me, it's been a massive learning curve. I've learned every day new things. There's not a new day that I don't learn stuff, and that's been incredible. So it's been quite fun too.
Yeah, great. So there's a couple of questions in the Q&A section. So Chima is asking, there's a lot of dependencies in the 5AI platform stack. How do you maintain that?
So yes, so we have we try and keep everything in. When I say we do continuous deployment, we don't only do all like on the top of the stack. We try and do it all the way down to the Kubernetes cluster and infrastructure. So it's one of those things that I could say everything is fully automated. We've all sorted out. There are still a bit of manual steps, but we are trying to continuously. Our ultimate goal is just to have all fully automated and taken care of. But it's a long process, so we're trying to work towards that. And sometimes, and it happens everywhere, a dependency will be broken, and then you have to go fix it. But we'll try and pick it up before that happens with a lot of testing and a lot of like automation. It's the goal with these things, like try and automate everything so you catch it before it actually breaks anything.
Yeah, great. And Megan is asking, hi Paco, what practices do you do at 5 to ensure that everyone feels like part of the team regardless of where they are based? So currently it is, so we used to, in the pre-COVID era, we used to every 3 months, every 3-4 months, we would have an all hands where everyone would meet. This picture is from one of them. And that was a good way of everyone interacting with everyone, because I was lucky enough to travel all around the offices, so I met a lot of people, but other people didn't travel that much, so it was a very good way of like for everyone to do it. We do nowadays, what we do is, because everyone's working from home, so everyone's sort of in like their own mini office. So we every couple of weeks we will have a show and tell where everyone will present what they've done on the sprint, so everyone else can see it. And we try and have some socials. We've had like online all hands with GatherTown, which there was a screen capturing one of them. We try and make sure that everyone feels part of that is not you're not isolated in a corner. We have, and in terms of the teams, everyone has a stand-up, because there's no one that works not only wolves. We have teams and people who do stand-ups every day, and
one way, and then we use Slack, and there's a lot of communication both for work, and there are games nights, so we try and keep a team together.
Great. I think that's all questions for now, but if you keep an eye on the stage tab, there's a Q&A section, so there might be some new questions showing up there. But thanks a lot for like a really exciting presentation, Francesco. And now it's time for another great speaker, Ioannis from Paddle, who's going to talk about Terraform automation. Thanks a lot.
Hello, Pavel.
Hey.
Can you hear me?
See you. And I just need to see the presentation.
Sweet. Give me a second.
Okay, great. And the floor is yours.
Cool, thank you. Cool, thanks everyone for joining today. What I'm going to describe today is how we use Terraform automation Paddle. And apologies in advance for anyone that is not familiar with Terraform, but you can understand at least the basic concepts we follow to ensure like we deliver our code reliable. But first, a little bit about me. As Pavel said, I'm Ioannis. I'm the SRE team lead at Paddle. I work with Paddle for almost 2.5 years now. I'm from Greece. At the moment, I live in London, and I come from a software engineer background. What we do at Paddle at the moment is we have a one-stop shop to sell your software. What this means is like you build your new software, you want the checkout implementation to sell your software. It's where we come in because we handle the tax for you, all the fraud checks, and what you have to do is just get a nice paycheck at the end of the month with your sales. And also what I'm trying to do now is bring reliability mindset to Paddle by following SRE practices such as SLOs. But let's dive into a little bit of the code. So Terraform is a way to manage infrastructure as writing code. So if you want to deploy the new service, you just write some kind of configuration file, you deploy it, and that's it. So it's the same practice with writing normal code. But why we need Terraform? We want to have our test environments as close to production as possible. So this will make things easier for testing. Everything you build looks exactly the same. For example, how you create a load balancer or how a service looks or anything really. So this templating will improve your reliability, and it will reduce the context switch when developers changing teams because all the infrastructure looks exactly the same. And the last one is you should give your developer access to your production, but you should give them access using tools and processes. Even if the access with Terraform is indirect, it will allow your teams to deliver without having bottlenecks around your department. And obviously, it's extra fun to play with Terraform. So the next thing I want to chat about is orchestrators. So what's an orchestrator? Orchestrator is just a simple GitHub repository. And we follow one simple pattern that one orchestrator is focused on one provider. By provider, I mean, for the first example, AWS. For example, imagine you have a Terraform AWS, which is a repository that manages all things AWS. So this can be anything related from networking, security, services, load balancers, pretty much anything you have in your infrastructure. A different one can be how you manage your database users and your database access. Again, different repository that is focused completely on that, how you manage access to your MySQL or Postgres databases. Similar and same question applies to everything. So you can have a specific one for how you manage your RDS, how you manage your Cloudflare, how you manage your Google Cloud platform, pretty much anything. And for every single orchestrator, we have some layers within the orchestrator. So there are 3 main layers, and Bootstrap is where we create all the Terraform dependencies that we need to run Terraform automation. This is usually an S3 bucket, IAM access, and KMS keys for encryption that we all need of them to save the state files. And this is the only layer that we plan and apply locally and commit the state file to the repo itself. The next layer is the foundation layer, and it's where you should configure more global settings for your infrastructure. For example, how you do networking, how you create clusters. And this is usually an optional layer when it comes to orchestrators because, for example, for how you manage database users, usually you don't have something global, so you don't need it. And service is probably the most important one. It's where most of your code is going to live. It's where you manage all your components that are part of the service. For example, you have a service called Awesome Service, and there you want to create an EC2, a load balancer, SNS, SQS. So all of this managed from this layer. And the last one is the Terraform modules, which is normal Terraform modules. And it's where you can have a template of how an ECS service looks, how Elastic Cache looks. So this way you achieve this templating, everything looks exactly the same. Now, within the layer, we have a directory per environment. We decided against using Terraform workspaces, if you're familiar, as we found them harder to understand and work with. And in our case, one environment means a completely different AWS account. In other situations, maybe an environment means a different region, depends how you structure your infrastructure. Within every layer and every environment, we have a backend.tf file where you specify what state file to use for this kind of automation. And the pattern we follow is one state file per layer environment combination, as we give you enough abstraction and safety that if you apply something on your development environment, it's not going to affect your production one. Then for every environment, we have different files like providers, versions, and it's a way to guarantee that we always use the same external dependencies, so we have no surprises. And within an environment, we have a file per component. So again, let's say you have an example service, you have example service.tf, which everything there is all the resources needed to deploy the service. And last, we use data sources to reference things out of this layer, and not plain text strings, as you want your Terraform to fail fast and not during apply stage. The next one is how we configure our GitHub repositories. Obviously, everything is in Git, as I mentioned, like version control gives you audit logs, gives you better access on the change management. Everything is easy. Some of the rules we follow is all the branches or the pull requests must be up to date with your default branch in order to allow merge, and we can enforce this by GitHub rules. I'll explain in the next slide why. And also we use code owners, where if you want your Terraform admins to always review, for example, the Bootstrap directory, they will be always review this, or it's how you can manage that this specific team gonna own this specific file, so they always have to review this file. And the next one is how we go and deploy all these changes using Git and Terraform. So we do GitOps. We do GitOps in a different than traditional way. What it means, whatever is on your default branch is the source of truth of your infrastructure to all environments. So if you go and replay the master build, it will be no changes, and we actually go and make sure that infrastructure looks exactly the same. For every single build, we run init, lint, validate, and plan. And believe me, the builds are fast and will take probably a lot of time before you have scaling problems. But the scaling problems usually are the most interesting and the best problems to have. Also, in the default branch, we run all the previous mentioned steps, but also it's where we apply the changes to every single environment. And after the apply finishes, it sends the proper Slack messages, so you know if it was correct, it was successful or not. So if it's not, you go and check what happened. And obviously, everything runs via Docker on RCI, and you use versions for everything, like what's your Go version, what's your Terraform version, because we want to guarantee that there will be no surprises during how we manage infrastructure. The other important thing is how you review your Terraform changes. Obviously, the most simple one is first you should review the config changes, so the code itself. So review the code, it looks okay, no, normal review process. The next one is to review the plan. The plan is, it gives you what is going to change. So we use a tool for that makes a comment to our pull request. You can see the link there with what is going to change. And it's responsibility for the reviewers to always review this and leave some comments on the author that maybe something looks wrong here. And again, as I mentioned before, we only review the plan if the branch is up to date with the default branch, because we want to guarantee that what is going to change it's actually true. And once we merge the pull request, it goes to the default branch and it applies to all environments. Other small bits that we found interesting and we use it a lot is we use tags. It will make everyone's life easier when it comes to who owns what, if you want to have better cost management. But we found these 5 tags very useful. One is like managed by, which is like usually Terraform, the environment you deploy, the component name, the system name, and the business unit. That can be engineering or, I don't know, success, support, different kind of departments within your organization. The next one, I'd recommend to think multi-region when it comes to AWS, for example, from day one, and how you structure your layers. The layer I presented before, it's easily scalable to be region-specific if you just pick a region between the layer and the environment. Another thing, when you run Terraform automation, you will see that concurrent builds can fail, and they can fail because they try to get the lock to run a plan or apply. How you avoid this is you use this flag, lock timeout, and it will when a plan tries to get a state file lock, it just wait for 5 minutes. If not, it will fail. If something unlocks, you're gonna get the lock and go on. And then I would suggest to lock down your Terraform and external modules version and only allow patches and security fixes to come in. This is mainly to avoid surprises, and it can be very interesting if you don't do that. And last one, try to upgrade your Terraform providers as regular as possible. And this is mainly to avoid big bang migrations. At Paddle, we did the Terraform migration from 12 to 14 for all orchestrators within 2 weeks. No drama there, but now we try to be more proactive in this and do it quarterly, review what we can upgrade and bring it to the latest versions. Some challenges and trade-offs we have with this approach. Obviously, with monorepos, the build time will increase, and at some point, you will start running plans in parallel per environment and layer. Sometimes the infrastructure changes from all the teams will be a lot, and often that's not a problem because your engineers are gonna have to collaborate and speak between themselves. But other times, orchestrators will not be touched for weeks, so it's not like that big of a problem. But it's challenging how you can manage it when it happens. Another challenge is how you test end-to-end a single change to an environment without going and merging your pull request. Usually we allow the option to apply always via RCI a change to a test environment without merging your pull request. But your brands, you need to be up to date with the default brands. And also when you do that, you are fully aware that if someone else merges their changes, then your changes will roll back. And as I mentioned before, we decided to use directory structure over Terraform workspaces. It's so much easier to understand and work with. Workspaces, they have their place, but we felt it's not the right one for us. And last one, that's some of my suggestions. I'd recommend to follow the previous structure as long as your department is less than 100 engineers. The number is a couple of magic numbers, so don't take it very seriously, but it's more like, I feel less than 100, this can work well. But when the times come, you can move the Terraform files with the service-specific configuration to a service repository and run the apply plan in the service pipeline. And if you follow the approach we suggested, then you're fully prepared to do that. And this is why we follow this approach. So when it comes, we can move this configuration to service repositories and not in the monorepo. The next one I suggest is don't go nuts with creating too many orchestrators. Try to be sensible. For example, if you manage databases, maybe it's good to have database standalone to one repo. But other than that, I'd recommend go as big as possible, and when times comes, split out things. And the last one, I'd recommend to use S3 as your backend to store your state files. Be very strict on who has access on these files, because sometimes you're going to commit secrets in there, which is fine because S3 can be very restrict, but you have to follow the appropriate patterns to make sure that only some people, or obviously only some automation tools, can access this and nothing else. And yeah, just go and do it. So this is me. And yeah, at Paddle, we're hiring to SREs, backend engineers, front-end engineers, product managers, pretty much everything. We try to double our department this year. So it's an interesting time to be around. So if you want to join, click on this link, send me something on Twitter, ask on the chat here. But yeah, that's me.
Hey, Giannis, that was amazing presentation. And I think, one super practical. Before I get to a couple of questions I have, there's a question from George in the Q&A section in the stage tab. Hey, Giannis, if all engineers can deploy new services, how do you make sure that extra costs, if they are low, and that the new services are actually needed? Are you based on specific data?
Yeah, assume like you can use from AWS something called the budget reports and budget alerts. So from there, and that's why I said if you use the tags, you can know exactly who owns the service, what's the service name, so you can build auto-reporting like based on tags, and then you can make the cost to the team. We're not at the scale yet that we have to do it, but it's something that if you use the tags, you can build this automation like easily.
Yeah, and another question from Kasun. Maybe can you tell us how you manage secret using GitOps approach?
Yes, that's a great question. So obviously, when you have secrets, you don't have them to plain text on the GitHub repositories. And how we do that, we use KMS keys from some very restricted accounts that any engineer can encrypt something locally and put it on Git, but only the Terraform user and some admins can go and decrypt the actual value from the GitHub. So this way, you have encrypted payloads on Git, but only some people can decrypt the actual value.
Yeah. Yanis, like your presentation on chat is getting a very, very loud round of applause. And you also brought a strong representation from the paddle team. Now, the question I would love to ask you is like, paddle is obviously like super fast growing business. How is the sort of engineering organization changes and how you expect it to change sort of in the coming years? And what challenges does it bring? I'm asking both from the perspective of your talk, but also the perspective of people who could potentially be interested in becoming part of Paddle.
Yeah, that's a good question. Like as I mentioned, at the moment we're trying to pretty much double our department in the product engineer department. So obviously there's lots of things to improve, lots of things to make better and better. I think the main challenges is how we can focus and build a good base on infrastructure. For example, everything looks the same, everything's deployed the same. After you have that, it will unlock us to deliver things faster, which comes, after you scale your product and your team. I don't know. It's always good tech challenges. For example, it's if you board a new seller that has a lot of users, this will bring you immediately lots of traffic to the platform. So it's like how you handle these situations. And at the moment, we're focusing more on B2B. So we expect a lot more bigger customers to come on board, and this will bring more traffic, more tech challenges, which is always interesting at least for me.
Cool. Well, Luke, enjoy the glory and all the positive comments on the chat side. And thanks a lot for amazing talk today. And
Perfect.
now
Thank
it's
you.
time for last speaker, Karen, who's head of engineering at Gravity Sketch.
Hello. Yeah. Hi.
Hey, good to see you. So let's check if you can share the presentation, because I can see you and hear you very well. That's perfect. So the floor is yours. And yeah, looking forward to listening to that, because that sounds quite exciting. So
cool. Yeah. Right. So I don't know like how many of you heard of a Gravity Sketch. Pretty much our flagship product is VR, and we are basically provide a tool for designers, for artists, or even for any individual, who want to freely express their ideas while they don't actually have this kind of engineering or mathematics background. So the tool we're providing is very different from traditional CAD tool. Like it requires a quite deep of mathematic background understanding of those engineering details. In order to use it, probably you need years of training. So Gravity Sketch is very different. It's basically we try to make it be very physical and direct to feel what you create while you are express your ideas. And traditionally, most of designers or artists or anyone, if you try to express your idea, especially with those 3D objects like a chair, a table, you have to do this kind of a 2D sketching first, and no matter whether it's digital or whether it's a pen and paper. And then next is you need to get someone know those mathematics stuffs and build a 3D model for you in CAD tool. And there are lots of this kind of forward, backward, communications. So it makes the whole idea expression extremely hard and difficult, inefficient. So basically, the way we provide is for any designer, artist, or even just normal people like me, if I want to do something. And even when I talk with our engineers, when we discuss some 3D modeling stuff, we could just simply draw it in 3D spatial world and very easily talk about it, like on pen and paper. Sometimes we feel this kind of frustration. How do we, discuss those 3D objects like in different dimensions? So yeah, that's pretty much what we did for our first feature. And behind it, pretty much we take care of those, mathematics stuffs and engineering details, or even just the UX, how handle it. So for users, they just simply use it. Here, I just used a very simple shader, a tessellation shader for you. In the app, you won't see it, but this is how actually you could view the tessellation, how the mesh is tessellated with this special shader in our app. So yeah, basically for users, they don't need to care about those details. They just use it. And another big part we're doing is this kind of a real-time collaboration. So this basically enables anyone to collaborate with others from anywhere. And no matter whether you are a designer in New York or your colleague is in London, so you can just cross this kind of a geolocation restriction, join the virtual room together, and create something together, or inspire each other, or even doing some review, presentation, all sorts of stuffs. Or probably one day in future, this kind of talk could be given, in Graphic Sketch virtual world, and we could use a more 3D object, and more physically, probably the audience could touch some of those flows in 3D rather than just simply watch those 2D medium video stuff. Yeah, that's the real-time collaboration part. And if I compare, like what's the special parts with our collaboration was MMO, because I don't know how many of you play this kind of real-time MMO game, but lots of real-time MMO games in the market, and also you play with other players together. But what's the difference behind those two? And actually, it's quite different. Although both of them, have the name real-time, but it's very different. All the challenges we're facing are very different. Here, I probably put a kind of extreme case. MMO is a very broad topic. Like lots of MMO actually don't have much technical challenge. Probably the most extreme one is a real-time shooter game, because it requires extremely low latency, and a very precise sync, and also the result matters a lot. It's irreversible. Like when you kill someone, headshot, and if there is a network jittering, you don't expect that guy will, come back to life. So that would be a very ridiculous result. So, but the challenges we are facing are quite different, because the fundamental difference is content. In MMO game, like the most stuff player could do is use this predefined content, and they either buy them, use them, or stack them. So it's very simple. Firstly, very simple states and a very simple data structure, and you don't need to worry about it too lots of low-level detail stuffs. But for Graphic Sketch, actually, users are creating content inside the virtual world. It's very different from MMO game. User don't create content. User only like do some combination of their content. but they don't create content. While in GraphicSketch, users are creating content, and also a huge amount of content. Those content size could up to hundreds of megabytes or even gigabytes. So how could we efficiently synchronize all those huge amounts of content, and how do we deal with another one is the complex input. For MMO game, even you play with the keyboard and the mouse, the input you can do is very limited. While inside VR, the input is unlimited, because not only just those buttons on the controllers, but also the rotation of the controller, position of the controller, and also lots of gestures generated by the controller could be part of your input. So inputs are much more complex, and the content generated by those inputs are highly complex as well, because we are simulating this kind of mathematical models behind it, like you see here in this slide. So although it's just a surface, but underneath, we need to define those points and how we can tessellate. So those contents are very hard to break. And also we need to guarantee that after user create those content, their data won't be lost. And that means that we have to constantly, persist a huge volume of data, and guarantee this kind of data integrity. And for example, when you change a material and save it, it won't break once you load it back. But on the other side, one thing I want to emphasize here is that real time is just one of our feature. We aim to build a kind of a really ecosystem that anyone can very easily create stuffs, and they easily express the ideas, easily share and collaborate with each other. And actually, lots of those stuffs don't have to be real time. And so we are facing all different kinds of challenges from other parts as well, like this kind of a cross-device, cross-platform. For example, VR, quite famous, is it lots of resources, CPU, GPU. But what about mobile devices like, for example, Quest? It's a VR device, but it has a very limited resources comparing with a PC Tower. And what about a Pad app? Actually, we released the app for iOS system, and we're using the same mathematic engine, the geometry engine underneath it. And the tricky part is that for VR, it has a very high frame rate requirement, and for Pad app, the frame rate would be very different. And what about on web browser? For example, on VR, no matter it's a VR or Pad app, they could be multi-threaded, but a web browser is a single-threaded. How are we going to deal with those performance issues? How we can make it as perform as those powerful devices, and how we could provide the whole ecosystem and make it scalable, so that hundreds, thousands, or millions users join it, they would feel the same. They won't suffer any problems. So yeah, I feel that's pretty much this kind of a dream we try to build, and also this kind of revolution we try to bring into the industry, or not the industry, but pretty much all industries. So basically, yeah, this is how we tackle those challenges. It's really not about a tech stack. I don't want to talk about tech stack here. It's nothing secret. It's not about, for us, it's really not about the technologies. It's all about our products, our vision and the dream. It really doesn't matter what kind of technologies we're using. The most important thing is that we use technology, we adopt technologies for the products we try to build, or for the pain points, the problem domains we try to address. We don't adopt a technology just for the sake of the technology. It's the same for the methodology as well. So that's why the engineering culture and value parts are very important. So for anyone here, basically we empower everyone and encourage this kind of ownership. Without ownership, it's hard to adopt any new technology or drive the product, drive the problem domain. So ownership is the number one thing we care about. And anyone here, from engineer to designer, they have a full ownership of the product, not only just the problem, the technical domain, but also the business domain as well. And they constantly ask why, not only for the technique we're using, but also for the product we're building. And that will give us enough, enough thinking on the users' empathy part and also on our solution part, whether this is the right solution or a resourceful solution at this stage to address specific problem domain. And also go deep, because we are not just the devs, we are engineers who want to understand how it works, why it works in that way, and why we use it. And also, we don't have a hierarchy. No matter like it's a Daniel, our CTO, or myself, we very hands-on. We work with every engineer together, side by side. Basically, it's like just like in the battlefield. We doing the battle together. So that's how we tackle all those challenges. The matter is about the talents we have and the values we value. It's really not about the technologies we're using. And yeah, that's pretty much it. Again, yeah, we're hiring, and you can find those positions on the website. But again, we don't staff for positions or vacancies. We hire, or we are looking for talents. So if there is no position, that's also fine. We could create a position for you. And yeah, I think that's pretty much it from me.
Okay, like that was a really great presentation, and it's so amazing what you're building. One question that we've got in the Q&A section before I get to my questions. What's been the most impressive gravity scale design project you've seen?
Most impressive. I feel every feature we introduced is very impressive. I can tell you that we have many times have this kind of experience when we talk to those designers, our users. They just said thank you to us in front of us, into our face. Like they appreciate it. Whenever we roll out a new feature, we receive massive thank you, from our communities. So I feel probably that's also this kind of strong motivation, to drive everyone in Gravity Sketch. That, yeah. It's just it's kind of amazing experience that it's a simple tool, but when you handle it to the right people's hand, they can create amazing stuff in front of you. Right? That's the impressive part, I think.
Yeah, absolutely. And Meg Gala is asking, since VR involves a lot of creativity, do you guys have a specific role to achieve that, or is that the responsibility of the engineers and VR mathematicians?
We basically encourage everyone to just do whatever they like, they enjoy the most in their work, because overall, everyone spends most of our time in work than in our life, unfortunately. Even more time in work than with our family. So we encourage everyone to find what they enjoy the most. And yeah. And so it's not we have a job title. For example, we do have a UX designer, but that doesn't mean UX design is the privilege of UX designer only. And it's not exclusive. Everyone who has an idea, could raise their idea, could get their voice heard by the whole company, and we could discuss. So yeah.
Yeah. And the last question from my side is around kind of like the technical challenges you're facing. Like, what are the exciting problems you're trying to solve? Like, you clearly solved some problems in a really cool way in the past, but when you're looking forward, like, what are the exciting problems that potentially, people who's gonna join you in the coming months will be working on?
We have, I think we have hundreds of challenges waiting for us to solve. So like, for example, from VR side to device end to backend to infrastructure to platform, like just like a Paddle or 5AI, like we also have a strong, very big platform as well. We have a small team, but we do have a big challenges as well. So it totally depends on like the challenges we're facing at a backend is very different from the challenges we're facing in VR, in our geometry model, or even in UX. Like we can, for example, VR is so new. We cannot just simply copy those 2D UX into 3D because that's not going to work. Although most of the VR companies actually did that and they failed. It's a totally, when you put the headsets on, I don't know whether you guys watch a Ready Player One or not. It's a very different feeling, you know, when you interact with the virtual world. The way you interact is very different from keyboard and mouse. And we cannot just simply copy this. So here also I want to emphasize that not only technical challenge, but it's more like a product challenge, like how we could address the product better. And technical stuff are always serving for product. So we might compromise some technology stuff in order to serve product. We might to tackle extremely hard technical problems in order to provide a product solution. So the all focus is the product, and we are very product oriented. But yeah, I hope that UX issue would make sense to you, this kind of difference or the challenge difference.
Yeah. Well, look, great stuff. That was the last presentation of today. Really exciting presentations from 4 completely different businesses with different challenges. Guys, feel free to reach out to our speakers directly, not only here, but on their LinkedIns. As I said, like all the jobs and some more content about these companies are on TechTree. You'll also be able to find the presentations from today's event there. And, we're looking forward to seeing you next month on another exciting event. So thank you all for coming, and have a great afternoon, everyone. And once again, big round of applause for speakers today.